The Chapter 12 overview, we're looking at limits here, and this one we're looking at a function. So we could look at the graph here. So there's kind of one question that is leading you into whether or not you do have a limit or you don't. So as you're approaching the x value, so in this case we're approaching x, we need to approach it from both sides. And the question is, are we approaching the same y value? And so as we're following in from the left, we could see that we are approaching this y value, and as we're approaching 2 from the right, we can see we are approaching this value. So if your answer is yes, we're approaching the same value, then the next question is, what is that value? And then for me, that answer is 4. If we were approaching 2, the x value from both sides, and we weren't, if your answer was no here, then the limit doesn't exist. And if we look in problems 1 and 2, we both have a graph to look at. And so in this case, you can see, yes, we're approaching a certain y value. Even though that value doesn't exist on the function, the limit does exist there. And then if we look at number 2, we're looking at this graph, and as we're approaching from the left-hand side, as you can see, we are going up. And as we're approaching from the right-hand side, we're also going up. Now, we're going up and we're approaching something, but we don't have a definitive value there. And so since we don't have a value that we're zeroing in on, and as you look at the next two problems, if we were to put this function into our calculator and calculate as we get closer and closer to our x value, and in this case it's 3, we'd see that that number just continually gets bigger. We're not zeroing in on a specific number. So in this case, the limit does not exist. And then looking at 3 and 4, we're going to use our calculators here. And then just make sure that you're in radian mode, and just make sure you're very diligent with your parentheses here. So you're going into y equals, you'll be putting this function into your calculator. And then what happens is we can't plug in. So in 12.2, we could just plug in values, or we could factor and do something. In this case, we can't. So we're going to be putting in numbers very close to the given x value that we're approaching. And in this case, it's 0. So the numbers are arbitrary. So the closer and closer you get to 0, the more accurate you're going to get. And so looking here, you can put in 0.1, negative 0.1, and I can put in positive 0.1. I just went out to 4 decimal places because I figure that's pretty accurate. So I put in negative 0.001 because that's pretty close to 0, and I did the same on the right-hand side. So I just put in these two values, and I'm simply going to compare them. If it's the same number, then I can conclude that their limit does exist. And in this case, it's wanting us to round to the nearest integer. So in your calculator, you might get it written in scientific notation. So you have negative 3.6 e to the negative 4th as a written out decimal. That is negative 0.00036. And that's when I plugged in negative 0.01. So just remember, when you're plugging in these values, you'll hit second on your calculator, trace for calculate, and one value, and then it'll ask you for which x value. So if you don't remember we did this in chapter 8 for plugging in values. And so I'll do the same for here. So you have to do it twice to compare values. As you can see, I get the same value. Since it wants me to round, the nearest integer is 0. So as you can see here, now the limit as x approaches 0 of this function, we can conclude that it's approximately 0. And then we're going to do the same process for number 4. So the limit as x is approaching 1 for 3 times the natural log divided by the quantity of x minus 1. Make sure you're diligent with your parentheses here as you put that function in. You'll still be going through that same process here when trying to evaluate. So second, trace for calculate, 1 for value, and my values that I chose. So once again, these are values can be changed for whatever you'd like. I just go out the 4 decimal places to make it a little more accurate. So since we're approaching 1, I have 0.9999, and then on the other side, on the right side of 1, I have 1.0001. And so as I plug in those values, I get something very close to 3, and I get something also very close to 3. And so since we have a value that they're both approaching, this does fit the definition of a limit. So as limit is approaching 1, I get 3.